Hey Tube, welcome back to the channel. It's been a very long time since we made the Leetcode problem. We're starting with the problem number 35, search insert position. Given a sorted array of distinct integers and a target called value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. You must write an algorithm within or with O of log n runtime complexity. That means basically we are forced here to work with binary search algorithm. And if you look at this example, we have this array, we have the targets number 5, we need to return 2 because it is in the second position. But how does this happen? In in a binary search, basically we have two pointers. We have left, oh no, we have left and we have right, and we have middle. The middle equals left plus right divided by 2, so it's 0 plus um, 1 0 1 2 plus 3 divided by 2. It will be 1.5. So math.floor it, or yeah, I guess math.floor, it will be 1. So we will have our middle equals to 3. So we'll say does 3, or does the element in the middle index equals the target, which is 5, doesn't equal 5. Okay, is it bigger or small? And if it's basically bigger than it, and since we are working with a sorted array, it's bigger. So basically, all the element on the left side doesn't work anymore. So we have right now two elements. So we will push the left to be middle plus 1. So the left will be here, the right will be here. When we try to do the same concept here, it will be still 3 plus 2 divided by 2 to be 2.5. If we floor it, we got 2, which is 5, and we return it, and that's it. Okay, and it looks like it's too much work, but in the code it's pretty easy, pretty simple. So we will have our two pointers. We have left, which will equals 0, as we said. We have right, which will equals left, no, nums dot length minus 1. And we need to create a while loop. Basically, while left is less than or equal right, basically while we can find elements to loop through. And we will create our mid. So let mid equals left uh, plus math dot floor right minus left divided by 2. And we say if mid, if nums of mid, sorry, if nums of mid equals target, we return mid. If that wasn't the case, else if nums of mid smaller than the target, that means basically we need to the target is in the right half, basically. That means, so we move left to be mid plus 1. So left equals mid plus 1. Else, which is the last thing, it will be right. Basically, if it doesn't equal it, if it's not smaller than it, it's bigger than it. That means target is probably in left. So we will move right pointer to be mid minus 1. And if we can find nothing, if we can still not can find the element, we return left. Okay, so let's try to run it. It didn't work. Why? What is he assumed? Let's me just see here what's going on. If mid again. Let's see what the wrong thing that I have done. If nums of mid less than target, left equals mid plus one, else right equals mid minus one. Here we return left. If nums of mid equals target, we return it. And yep, I guess it should work. Let mid equals left plus mid dot floor, right minus. Oh, I made this problem. Let's run it again. Yeah, it works now. Okay, I guess some of you will ask me why we use plus left. So if we know understand that, so let's just give a deep dive in why basically we use left plus part is essential here. This is quite essential one. So imagine that you're trying to find the middle of a special section of a long street. Okay, so you don't want the middle of the entire street, just want the middle of your section, of only this section. Okay, so this is your starting point on the street. It's basically being the specific section you are inserted. Okay, so this is your end, like when you have left, basically this is your starting point, and right, it's your end point. So right minus left, it will calculate the total length of your specific section. Okay, math.floor in this one, this basically section, this tells you how far you need to walk from your starting point to reach the middle of your section. It's basically an offset or a distance. Okay, so if left is your current starting index and you figure out that the middle is x positions away from left, then the actual index of the middle element in the array is left plus x. Do you get what I mean? Okay, so again, if math.floor, again, let's try to understand what this do. This section, it tells you how far you need to walk from your starting point, which is left, to reach the middle of your section. Okay, it's a distance basically. Okay, and left is a starting point, right is the end point, and left minus right or right minus left, this calculates the total length of your specific section. Okay, so if left is your current starting index and you figure out that the middle is x positions away from left, then the actual index of the middle element in the array is left plus x. It's pretty easy to understand. If even you try to remove x, remove this and try to run it, it will not work for anyone. But when you put again, you run it, it works. And yeah, that's it. It's a pretty easy problem to understand. I guess the only trick here is the left to plus. You just need to be aware of this one. And yeah, that's it for this video, and see you in the future.